Hey, I'm Christopher Day, working as a master's student under Dr. McFarland here at Brigham Young University. And I just wanted to give a quick presentation on the work I'm doing involving the mode choice part of the simulated on-demand transit vehicles in this project. So here on this slide, we see the entire overview of the project and the process of how we're analyzing on-demand transit vehicles. I'm involved in the center part, the mode choice model. The graphic makes it look like a singular mode choice model is to be built and then inserted into a multi-agent simulation and the multimodal optimization. However, in reality, this is not the case. Really what's happening here is a separate mode choice model is used in the multi-agent simulation as well as a separate mode choice model in the multimodal optimization. In addition, an activity-based model is used to create the daily activities and trips that are fed into the multi-agent simulation. The activity-based model also has its own mode choice model. So here, highlighted in blue, these three different moving systems all have their own mode choice model. The daily activities and trips part, the multi-agent simulation part, and the multimodal optimization part. It's been primarily my job to ensure consistency between these three moving parts. So I really just wanted to go through now and explain a little bit of how I am ensuring consistency in these mode choice models. Now, a possible thought for creating this consistency could be to simply not use a multi-agent simulation, but instead only use the activity-based model as the primary source for modeling the travel behavior. We've opted not to do this though because activity-based models in nature do not represent ride-hail and microtransit services very realistically. So for example, here on the bulleted list, it explains that activity-based models really only use travel time and costs as factors in considering if microtransit is a good mode option. On top of that, it uses a singular average wait time for every user that wants a microtransit vehicle. So everyone, for example, may have to wait exactly 8 minutes every time before using an Uber. That's not very realistic. You know, sometimes it takes 30 minutes, other times they're really close by and it takes only 3 minutes, right? So another thing activity-based models do is always allow the option to take microtransit. It's always available. That's also not very realistic, right? So for example, depending on what time of day it is, maybe a microtransit option isn't available. Or maybe all the available vehicles are taken up right now and it just makes sense to pick a different mode of transportation. Simulation-based models address these concerns. The agents actually request to take a ride, just like they do in real life. With Uber, you get on your phone, you make a request. When that request goes through in the code, though, a variable wait time is assigned to those agents depending on how many vehicles are available, how close a certain vehicle is to their location, if that agent is willing to carpool with other users, etc. Also, sometimes depending on these factors, a microtransit option may not even be available. So, with a micro-simulation-based model, all of these questions and concerns are addressed and taken into account, more closely mimicking the thought process of a user in real life. That's why it is essential to use a simulation-based model and therefore needing to create consistency between the mode choice between them. Already I've more closely aligned the mode choice model of the simulation tool we are using with the activity-based model we are using. For example, I've made each mode choice sensitive to a tour purpose. This is important because there are different values of time for different tour types. A person off to work a little late may value their time a little more than a person going out for an ice cream cone. I've also made it sensitive to vehicle ownership and availability. Someone who shares their car with 5 other family members may not choose to drive a car as often as someone who lives alone, for example. Demographics are also taken into account, like age, income, etc. I have also integrated walk access and egress to transit. And I've even inserted the option to carpool and teleport in the model. All of these additions from the activity-based model inserted into the multi-agent simulation tool has created a lot more consistency between the two. For example, here are a few results of the changes to date, and a quick example of how the improved simulation choice model is working thus far. If you look closely, you can actually see that maybe the normal simulation-based model is working better, at least with the car modes. However, these are results for an uncalibrated model. With some calibration, that won't be the case. These results are interesting though because it shows that path, person, and location variables that were added into the mode choice all affect the mode decision in major ways. Along with calibration, the next steps really involve how to determine which mode options should be given for each trip on a tour. An activity-based model provides mode choices of the primary tour activity. Like if a person wants to go to work by train, the activity-based model knows that they will either walk or take transit to the gym. Currently, the simulation model bases mode choice on the first trip of the day, or the trip to the gym, and then figures out a way to get to work. This isn't the way people plan their days, though. Also, the activity-based model knows that when someone leaves for lunch from their work, they're coming back to work, meaning they can leave their car and maybe just walk there. In the simulation model, though, if someone goes out to lunch, they'll most likely are going to take their car to the pizza place as to not abandon their vehicle for the rest of the day. Again, that's really isn't the natural way, and the next steps are to fix this type of consistency. Thank you.